Okay, we're on page 84 of the note spiral, and this was an FRQ problem from 2003 on contingency tables and independence. A simple random sample of adults living in a suburb of a large city was selected. The age and annual income of each adult in the sample were recorded. The resulting data are summarized in the table below. What is the probability that a person chosen at random from the sample will be in a 31 to 45 paid category? So 31 to 45. And it's like, oh, 89 of them are in that category out of 207. So I need to make sure I record the fraction because this qualifies as my work shown. And 89 divided by 207 is 0.43. And if I did that, I'm going to get full credit for part A. What is the probability that a person chosen at random from those in the sample whose incomes are over 50? So now I'm looking at, I've restricted myself to the over 50. Will be in the 31 to 45 age category. So this is essentially saying, given that they make over 50, and anytime I have a given, I'm going to have an intersection. So given, well, how many were in the over 50? Well, 96 were. And the intersection is 35. So this ends up being 0.365. All right. So that's my work shown. Because once again, my intersection looks like two streets. It said is out of the 50,000 category or over 50,000. Based on your answers to part A and B, is annual income independent of age for the given category? Well, they said based on A and B. So if I'm looking at it based on A and B, I'm like, I'm not sure how that's related. But if I've made myself this note, it's like, oh, I remember something. All right. Here's what I remember about independence, because they're asking about independence. So I need to show independence. So I need to somehow or another relate all this together to show independence. But here I have an intersection. And that should clue me off because I have an intersection. Whenever I have the intersection, I can go, well, probability of A and B over the probability of B equals the probability of A. And this is only true if independent. That's only true if independent. Well, wait a second. If I look at this, this could be A, this is B. There's my intersection right there. So intersection, so my intersection has to equal this. So basically I can sit there and go, you know what? I've already done that. That's 0.365. And this is 0.43. Well, obviously those are not equal. Therefore, the events age and income are not independent. The events are related. Okay, this would have been a full credit response. That would have got me full credit for here. This is full credit for there, and that's full credit for there. All right. Now, I recognize this. This is doing it with conditional probability, and remember what clued me off that I had to use the conditionals. First off, they said independence, so I know I'm looking for some way to show independence, but they said based on A and B, so I needed to use the parts here and here. And it's like, oh, this is the intersection. And because that's the intersection, I remembered this, okay? Because this is essentially A intersect B over B. Now, I recognize that conditional independence is difficult for some students, so I'm going to look at this in a way that would have gotten partial credit. And because I mean, as important as this is, you've got to know the multiplication rule. Multiplication rule, if I had approached it that way, I would have said the probability of A and B equals the probability of A times the probability of B. Well, the intersection would be 35 over 207. And then we have A is 89 over 207 times 96 over 207. Had we gone that route, 35 divided by 207 is 0.1691. I'll slide that all up so you can see it. Sorry about that. And then we have 89 divided by 207 times 96 divided by 207 is 0.1994. And then we need to write our conclusion statement. You have to have the conclusion statement. So, how did I do this real quickly? Once again, if I use the multiplication rule principle, A was 89 out of 207, B was 96 out of 207, and the intersection was 35 over 207. A and B equals A times B. All right. And that's only true if independent, because they were not equal, they're not independent. All right. With a conditional, A intersect B over B equals A. Well, my intersection was 35, and we did that here. All right. So this is the intersection over given, and that's 0.365. And then A was the 0.43 that we got up here. Okay? All right. Hopefully that helps. And that's all the notes for this particular unit, with the exception of the review.